The Master Electrician exam in the St. Louis area is a 4-hour, open-book exam based on the 2020 National Electrical Code, also known as the NEC. The exam covers a wide range of topics related to electrical theory, installation, maintenance, and safety. This includes general electrical principles, wiring methods, overcurrent protection, equipment installation, raceway systems, lighting systems, motors and transformers, and special systems such as emergency generators and solar photovoltaic systems. Calculations comprise a significant portion of the exam. Be prepared for questions on voltage drop calculations, opacity calculations, load calculations, transformer calculations, and conductor sizing. To succeed on the exam, firstly, thoroughly review the 2020 NEC, especially the articles related to the topics listed above. Secondly, practice calculations to improve speed and accuracy. Thirdly, bring a calculator and the NEC code book to the exam. Fourthly, familiarize yourself with the exam format and time constraints. Fifthly, manage time wisely and prioritize answering questions that one is most confident about. The exam is administered by Pearson VUE. Registration and scheduling information can be found on the Missouri Department of Labor website. The exam fee is currently $130. Passing the exam is a requirement for obtaining a Master Electrician license in the city of St. Louis. Let's delve deeper into each of these areas. First, general electrical principles encompass a wide array of foundational concepts. This includes understanding Ohm's law, which dictates the relationship between voltage, current, and resistance. The formula for Ohm's law is voltage equals current times resistance. Being able to apply this formula to series and parallel circuits is crucial. Series circuits are circuits where components are connected one after another, so the current is the same through each component, but the voltage is divided among them. Parallel circuits are circuits where components are connected side by side, so the voltage is the same across each component, but the current is divided among them. One also needs to understand Kirchhoff's laws. Kirchhoff's current law, or KCL, states that the total current entering a junction must equal the total current leaving the junction. Kirchhoff's voltage law, or KVL, states that the sum of all voltage drops in a closed loop must equal the sum of all voltage sources in that loop. Another key aspect of general electrical principles is understanding alternating current, or AC, and direct current, or DC. Direct current flows in one direction only, while alternating current periodically reverses direction. In North America, the standard AC frequency is 60 Hz. Also, understanding power calculations is vital. Power is the rate at which energy is transferred and is measured in watts. In DC circuits, power equals voltage times current. In AC circuits, power calculations become more complex due to the phase relationship between voltage and current. Power factor, which is the ratio of real power to apparent power, plays a significant role in AC power calculations. Wiring methods are detailed in Chapter 3 of the NEC and involve the types of wiring allowed for different applications. These methods include non-metallic sheath cable, often referred to as NM cable or Romex, which is commonly used in residential wiring. Another type of wiring method is metallic conduit, such as electrical metallic tubing, or IMT, and rigid metal conduit, or RMC, which are often used in commercial and industrial settings to protect conductors from physical damage. Another type of wiring method is cable tray, which is used to support insulated conductors and cables. Each wiring method has specific requirements regarding insulation, support, and allowable uses. Overcurrent protection is covered in Article 240 of the NEC and is designed to protect electrical systems from overloads and short circuits. Fuses and circuit breakers are the two most common types of overcurrent protective devices. Fuses are one-time use devices that melt and interrupt the circuit when the current exceeds a specified value. Circuit breakers are reusable devices that trip and interrupt the circuit when an overcurrent condition is detected. Circuit breakers can be reset after they trip. Properly sizing overcurrent protection is critical to prevent damage to equipment and conductors. The NEC provides tables and guidelines for determining the appropriate size of overcurrent protection based on the ampacity of the conductors being protected. Equipment installation involves the proper installation of various types of electrical equipment, such as panels, disconnects, and appliances. The NEC specifies requirements for clearances, grounding, and support of electrical equipment. Proper grounding is essential for safety and helps to prevent electrical shock. Equipment grounding conductors, or EGs, provide a path for fault current to return to the source, allowing the overcurrent protective device to trip. Raceway systems provide a physical pathway for conductors and cables. Common types of raceways include electrical metallic tubing, rigid metal conduit, and flexible metal conduit. The NEC specifies requirements for the size, support, and installation of raceways. The fill capacity of raceways is also regulated to prevent overheating of conductors. Lighting systems cover the installation and control of lighting fixtures and systems. The NEC provides requirements for the type of lighting fixtures allowed in different locations, as well as requirements for lighting control. Energy efficiency is an important consideration in modern lighting system design. LED lighting has become increasingly popular due to its high efficiency and long lifespan. Motors and transformers are key components in many electrical systems. The NEC specifies requirements for the installation and protection of motors and transformers. Motor overload protection is essential to prevent damage to motors due to overheating. Transformer protection is also important to prevent damage due to overcurrent or overvoltage conditions. Special systems include emergency generators and solar photovoltaic systems. Emergency generators provide backup power in the event of a power outage. The NEC specifies requirements for the installation, testing, and maintenance of emergency generators. Solar photovoltaic systems convert sunlight into electricity. The NEC provides requirements for the installation and interconnection of solar photovoltaic systems. Now let's move on to calculations. Voltage drop calculations are performed to ensure that the voltage at the end of a circuit is sufficient to operate the equipment connected to it. Excessive voltage drop can cause equipment to malfunction or fail. The NEC provides guidelines for allowable voltage drop in different types of circuits. Factors that affect voltage drop include the length of the circuit, the size of the conductors, and the current flowing through the circuit. Ampacity calculations are used to determine the maximum current that a conductor can safely carry without overheating. The NEC provides tables that list the ampacity of different types of conductors based on their size, insulation type, and installation conditions. Correction factors and adjustment factors must be applied to the ampacity values in these tables to account for ambient temperature and the number of current carrying conductors in a raceway or cable. Load calculations are performed to determine the total electrical load on a building or electrical system. The NEC provides methods for calculating the demand load for different types of occupancies and equipment. Demand factors are used to account for the fact that not all loads will be operating at the same time. Transformer calculations are used to determine the proper size and rating of transformers. Transformers are used to step up or step down voltage levels. The turns ratio of a transformer determines the voltage transformation ratio. The kVA rating of a transformer determines the amount of power that it can deliver. Conductor sizing involves selecting the appropriate size of conductors for a given application. The NEC provides tables that list the ampacity of different types of conductors. The size of the conductors must be sufficient to carry the load current without exceeding the allowable voltage drop. Now let's talk about some specific articles in the NEC that are particularly important for the Master Electrician exam. Article 210 covers branch circuits, which are the circuits that supply power to outlets, lighting fixtures, and appliances. Article 215 covers feeders, which are the circuits that supply power from the service entrance to the branch circuits. Article 220 covers load calculations for branch circuits, feeders, and services. Article 230 covers services, which are the conductors and equipment that connect the utility power supply to the building's electrical system. Article 240 covers overcurrent protection, including fuses and circuit breakers. Article 250 covers grounding and bonding, which are essential for safety. Article 300 covers wiring methods, including the installation of conductors and cables. Article 310 covers conductors for general wiring. Article 430 covers motors, motor circuits, and motor controllers. Article 450 covers transformers. Article 500 to 516 cover hazardous locations. Article 690 covers solar photovoltaic systems. Practicing calculations is crucial for success on the exam. Work through as many practice problems as possible to improve speed and accuracy. Pay attention to the units of measurement and make sure to convert them correctly. Use a calculator to avoid making arithmetic errors. Familiarize oneself with the NEC tables and learn how to use them to find the information that is needed. During the exam, firstly, read each question carefully and make sure to understand what is being asked. Secondly, identify the key information in the question, such as the voltage, current, and resistance. Thirdly, use the NEC to find the relevant articles and tables. Fourthly, perform the necessary calculations. Fifthly, double-check the answers to make sure they are reasonable. Time management is also critical on the exam. There are only 4 hours to complete the exam, so it is important to manage time wisely. Prioritize answering questions that one is most confident about. If one is stuck on a question, move on and come back to it later. Don't spend too much time on any one question. It is a good idea to bring a calculator and a copy of the NEC to the exam. Make sure the calculator is one that one is familiar with and knows how to use. The NEC is an essential resource for answering questions in the exam. Familiarize oneself with the NEC before the exam so that one can find the information that is needed quickly and easily. Remember that the exam is open book, so one can use the NEC to look up information. Don't try to memorize the entire NEC. Instead, focus on understanding the key concepts and how to find the information that is needed. The Missouri Department of Labor website has information about the Master Electrician exam. Visit the website to learn more about the exam format, content, and registration process. The website also has a list of approved testing centers.